Okay, geometry students, this is lesson 11. Mr. Tanis here. We're talking about similar solids. So we're talking about length, and then we're going to get into area, or surface area and volume as well, how those things are related when you make an object bigger. So we talked about similar triangles, similar figures all year long, but similar solids have exactly the same shape, all right, but not the same size. All right, two solids are similar if the ratio of their corresponding, we'll say linear, measurements are equal. All right. So what is a linear measurement then? All right, there's tons of examples we can give of linear measurement, but anything that's one-dimensional in length. So let me write these. So we have length, width, height, slant height, perimeter, radius, diameter, circumference. These are all quantities that we can compare to find the scale factor and to find out if figures are indeed similar. So let's take a look at an example then. Here are two rectangular pyramids. All right, we're given the height, it looks like, in both. We're given the width of both, of the base, and we're given the length of the base. So we're going to compare all those dimensions. So height of the big to height of the small has to equal, width of the base of the big to width of the base of the small, which has to be equal to length of the base of the big to length of the base of the small. And all those are equal to 4. So yes, these are similar. And the ratio then is 4 to 1. And if you say 1 to 4, that's fine with me as well. Obviously, it's 4 to 1 going from the big to the small, but it's 1 to 4 going from the small to the big. So basically, this is these are similar figures. These are similar pyramids. One is just 4 times bigger. All right. Now, when I say 4 times bigger, I mean the lengths are 4 times bigger. We're going to find something interesting about the area and the volume. They don't necessarily follow that proportion. All right, let's take a look at number 3 then, I guess. Okay, if these are similar solids, similar cylinders in this case, then we can look at the dimensions and say, okay, we're given the height in each. So let's do height of the big compared to height of the small, and that has to equal, we're given the diameter of the big. So let's compare that to diameter of the small. Make sure we do diameter. They only gave me radius, so I need to make sure I'm smart enough to say I need to double that to get 20. All right, let's find out if these are equal. 5 goes into both of these, top and bottom, turns into 6/5, and 4 goes into top and bottom, makes it 6/5. So they're both 6 over 5. So yes, they are similar, and the ratio is 6 to 5 or 5 to 6, depending on what way you're going, which is 1.2. So basically, one is 20% bigger. The bigger one is 20% bigger than the small one. That's what 1.2 means. All right. Now, that's just length, but we can talk about surface area and volume. All right. So if the scale factor is what we're going to call A to B, that's what we were just finding up here. This 6 to 5 would be our scale factor, A to B. That is a quantity that compares any dimension of length. So it could be length, the width, the height, the slant height. Any one-dimensional quantity is A to B comparison between two similar figures. The surface area is A to B squared. So we'll say A squared to B squared. And the volume is A cubed to B cubed. Now let me kind of try to explain why that is. It's pretty simple. So if I start off with a cube, and this cube has, length and width and height of all 1. All right. Then, and I make it twice as big. All right. So twice as big meaning my ratio now of length, all right, is A to B. He'll do a fraction A to B. All right, which in this case is 1 to 2, because I'm going to make this thing twice as big. All right, so now I'm going to make a cube that has the side lengths that are about twice as big. Okay, so our length ratio from one similar cube to another is 1 to 2. This one is basically, I'm going to say twice as big, right? Meaning the side lengths are twice as big. But the question is, what happens to the area? All right. The area now, we know, is A to B squared, so it's going to be 1 to 4. And you can see that because if you look at the area of this figure, right, the surface area, we can just add up all the sides, or we can do our surface area formula, right? Our surface area is area of the base times the height. Area of the base is 1, and the height is 1, so our surface area of this object is just 1, right? Now, the surface area of this one, the bigger one, I'll do it right here, surface area is equal to area of the base times the height. We did I'm sorry. I'm doing volume here. Surface area is, let me try this again. Is lateral area plus 2 bases. All right, now lateral area is perimeter times height. All right, so perimeter is 4, the height is 1, and then the bases are both 1. So I have 6 for my surface area. See, better. Okay, so surface area of the small one is 6. Surface area of the big one is lateral area plus 2 bases, and we get the lateral area is perimeter times height, and the perimeter in this case is 8. The height is 2, and the area of the base is 4. So that's 16 plus 8, which is 24. All right, so 6 to 24 is the comparison of surface area, which is 1 to 4, just like we thought. So the area is 1 to 4, all right, if you actually look at this. All right, now the volume is, we know, a to b cubed. So I'm going to write a to b cubed. All right, so it's going to be 1 to 8 for the volume. We know that, right? Well, let's take a look at the volume formula. Let me show you that. So the volume is area of the base times the height. Area of the base is length times width, which is just 1, and the height is 1. So once again, the volume is 1 cubic unit, all right, for the small one. The big one, volume is area of the base times the height. So area of the base is, in this case, 4, times the height of 4 is 8. So 1 to 8 is our ratio for volume. So basically, when we double something in length, we quadruple the area and we multiply the volume by 8. All right, I know that's weird, but you can fit 8 cubes inside of this one. You can look at it like that. Imagine drawing 8 cubes inside here. There's 4 in the bottom and 4 in the top row. But basically, when you double the length, you actually multiply the volume by 2 cubed, or 8. All right. Another way to look at this is the formula for volume is length times width times height. When you double the length, you also double the width and you double the height. So you end up multiplying the volume by 3 times, which is 8. So you end up multiplying the old volume, length times width times height, by 8. That's what these 3 2's are. So, you know, you can look at this different ways, but basically this is a really important concept to wrap your head around, because you will see this again later in life. You will use this because there's multiple times where you are thinking about, you know, area versus volume when you order wood chips, for example. I know I use that example, but or concrete or sod or whatever it is, soil, whatever it is you're ordering in quantity like that, you know, comes in cubic units, and you might measure a linear distance, and you need to know, you know, if you're getting a tile at Home Depot or Lowe's that's twice as big as another one, understand that that's actually 4 times the area. That tile has 4 times the area, and you're going to measure your floor in terms of area. So this is an important concept. When you double a length, you actually multiply the area by 4 and the volume by 8. And that's what all this says here. All right, so let's trace a couple examples then. The scale factor between these two, if you look, you know, it's 1/2 or 1 to 2. All right, so I'm going from 3 to 6 and from 7 to 14. I'm doubling going this way. All right, so the surface area ratio then would be 1 to 4, and the volume ratio would be 1 to 8. All right, pretty straightforward if you just use these this information above here. Let's just try another quick one. The you know, A to B ratio of length is 4 to 6 in this one. 7 to 10.5 is the same thing. All right, and if you reduce, you get 2 to 3. So that's the scale factor, 2 to 3. The ratio of any length is the scale factor. The surface area, we need to square both of these, so it's going to be 4 to 9. And then for volume, we need to cube both of these, so it's going to be 8 to 27. All right. So moving on, when we're given the surface area volume, can we work backwards to find the scale factor, or the ratio of A to B? All right, so in this case, they give us the ratio of surface area. So I'm going to write that as 4 to 25, or 25 to 4. All right. Now, I like to sometimes write this out like this. A to B is, we don't know what that is, but I know A to B squared is 4 to 25. And A to B cubed is something we don't really care about in this problem. Actually, I'm sorry, we do. So let's square root both of these, and we get 2 to 5 for the ratio of length, or the similarity ratio. And the volume ratio, we're going to then cube both of these quantities, because that's A to B, so we need to have A to B cubed here. All right, and that's going to be 8 to 125. Now, the answer key has these quantities switched, but there's nothing in the directions that indicate whether they want us to do the similarity ratio from small to big or big to small. So we would have to accept these answers switched like this. If you put 5 to 2 or 25 to 4 or 125 to 8, that we get what you're saying. If the directions say give the similarity ratio from the small to the big. Now they're being specific about the fact they want the small to the big like this. But otherwise you can switch these. All right, we're just comparing the two quantities. Let's try another one. Let's try number 8. Okay, so I'm sorry, let's try 7 since this one's volume. All right, so we're going to write out our length is a to b, surface area is a to b squared, and volume is a to b cubed. Just to keep this organized, this is something I hope you keep writing out because it's really important to remember. All right, in this case, they give us the volume, small volume to big volume. So I'm going to use this equation basically to cube root both sides of it to get my ratio of a to b, right? Because if I cube root this, the cube goes away, and I can cube root both sides of an equation, right? So basically, I'm just going to cube root this quantity, all right? Now, cube root in your calculator, something, I don't know if you have access to this calculator online or on your TI-30 or whatever it is you're using, but there's different ways to cube root. Under math, there's a cube root button, or there's this X root where you can do any root. That's also on your calculator. You need to find it. Google how to find it if you can't. I don't know what calculator you have, but on my calculator, it's cube root here, and it's 162 to 384, and it gives us 0.75, and that's 3/4. All right, so 3/4 is my ratio of length, and I can square both of those quantities. 9 to 16 is my ratio of surface area. All right, let's just try a couple more. 9 and 11. 9 says solid A is similar to solid B. The ratio of height, so we're given the ratio of length. So let me write these out. All right, length, surface area, and volume. Length they gave us is 7 to 3. All right, so I can get, and they're asked about volume. So volume, I'll just cube both of these right away. 7 cubed, and that's 343 to 27. That's the volume of the big to volume of the small. All right, and we kept it the same because they gave us big to small. So solid A is big and solid B is small. I'm sorry. Yes, that's correct. All right, let's try 11 then. Okay, once again, I'm going to write out these quantities, these 3 quantities for length, surface area, and volume. All right, and it says that we're talking about a diameter of cylinder A to a diameter of cylinder B, 24 to 30. So that is a ratio of length, one-dimensional ratio. That's the similarity ratio then, which we can simplify to 4/5. 6 goes into the top and the bottom. All right, now they asked us about the ratio of the volume again. So once again, we're just going to cube both the A and the B. All right, so 4 cubed is 64, and 5 cubed is 125. So there is my ratio of volume. All right, I hope this video helps. I hope the homework goes well. Once again, let us know as soon as you have questions, and have a fantastic day.